All right, on page 497, to find the horizontal asymptote, you're going to go by these rules. You might want to write these down in your Cornell notes. When the degree of P of x is less than the degree of Q of x. Now, P of x is the numerator, Q of x is the denominator. So when the degree of the numerator is less than the degree of the denominator, then your horizontal asymptote is y equals 0. For example, x squared plus 3x over x to the 4th minus 6. The degree of the numerator is less than the degree of the denominator. You don't have to divide it, don't have to do long division. Automatically, y equals 0. Horizontal asymptote at y equals 0. Second rule, when the degree of the numerator is equal to the degree of the denominator, for example, x squared minus 4x over 2x squared plus 7x. When your exponents, the degrees are the same, then you go by the numbers out front. So this would be a 1 over 2, which it says a divided by b, 1 divided by 2. So your horizontal asymptote would be y equals 1/2. Third one, when the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. For example, if it x to the 4th plus 2x over x to the 3rd minus 6x. One more time, when the degree of the numerator is greater than the degree of the denominator, there will not be a horizontal asymptote at all. Okay? Now, last one, when the degree of the numerator is 1 more than the degree of the denominator, like this one is 4 and this one is 3, or it could be 6 and 5, or it could be 2 and 1, then you will have a slant asymptote. And we'll talk about slant asymptotes in a little bit, but a slant asymptote looks like a line which the graph will not touch. Questions? All right, turn to page 499. Example 1b. Okay, 1b. I'm going to make this a little bit bigger so I can see it. Okay, so we're going to look at first, we're going to look at to see if it has vertical asymptotes, if it has horizontal asymptotes, everything, we're going to look at that first. So what are we going to have to do here? Now that we know our rules, we do not have to do long division and divide that out. Okay, let's look at the degree of the numerator is 2, and the degree of the denominator is 1. What does that tell us?
Slant.
It has a slant asymptote. Okay, so we know it's going to have a slant asymptote. When we know it does, we have to divide it out. When it has a slant asymptote, you have to do long division. Let's go ahead and do long division. X squared plus x minus 2 divided by x plus 3. Remember, 2 terms here means we're going to start our answer right here above the second term. How many times will x go into x squared. X. Then I'm going to distribute the x. X times x. X squared. X times 3. 3x. What do I do after I distribute that? Change your signs. Make that minus. Make that minus. Those will cancel. Negative 2x minus 2. Because I bring down the last number here. How many times will x go into negative 2x?
Negative 2 times.
Negative 2 times. Distribute. Negative 2x. Negative 6. Change the signs. Plus. Plus. Negative 2 plus 6 is 4, and those cancel. So what I'm looking for is my quotient. My quotient is going to be my slant asymptote, period. So y equals x minus 2. Y equals x minus 2 makes a straight line. And your slant asymptote will be a line. So y equals x minus 2. So what I'm going to do is I'm going to graph that over here on my graph. How can I graph y equals x minus 2? Yes.
You're going to go down 2
From the origin.
and you're going to go up 1 over 1.
Very good. Up 1 over 1, up 1 over 1. That is going to be my slant asymptote right there. Now, how did we know it had a slant asymptote? Somebody.
Because there was
The degree what?
Was
one
one
more.
one bigger.
Okay, the degree in the numerator was 1 bigger than the denominator. So when it has a slant asymptote, you have to do long division. All right, next thing we're going to do, we're going to look for vertical asymptotes, or we're going to look for holes in the graph. So how am I going to get factors? What am I going to do to my numerator? To the numerator,
FOIL.
I'm going to factor it.
Oh, just kidding.
Okay, so if you don't know how to factor, you have to put it in a what?
Box.
Box. The first term goes in the top left box. Last term, bottom right box. Multiply the two together. X squared times negative 2 is negative 2x squared. I need to find all the factors of negative 2x squared. Negative 2x times 1x. 2x times negative 1x. Now I want them to add up to be 1x. What two add up to be a positive 1x?
2x and negative 1x.
2x and negative 1x. What do these have in common?
X.
X. What do these two have in common?
Negative 1.
Negative 1. What do these have in common?
X.
X. And these?
2.
2. My factors will be x plus 2 and x minus 1. Now I need to know, does it have a vertical asymptote or does it have a hole? What's the difference? Remember from yesterday, what's the difference in a vertical asymptote and a hole? They're both discontinuities, but what is the difference? How do I know what it has?
A hole is when there's the same factor in part and part.
Okay, good. if it had the same factor on top and bottom, like if they both had an x plus 3, that would make it a whole. It doesn't have the same factor on top and bottom, so it just has a vertical asymptote. How do I get a vertical asymptote?
Set that to 0.
Set the denominator equal to 0. Subtract 3. X equals -3. That right there is my vertical asymptote. So I'm going to draw it on my graph, a vertical asymptote. One more thing you need to look for. When I start graphing this, and I'm going to show you how to do the chart in just a minute, but when I start graphing this in a minute, I really need to know where it crosses the x-axis. Okay, that's going to be very important. So the way you find where it crosses the x-axis is you set your numerator equal to 0. So if I set x plus 2 equals 0, x equals -2, and x minus 1 equals 0, x equals 1, I know that my graph is going to cross right there at -2, and I know it's going to cross right there at +1. Those are important points. Okay, how did I get my x-intercepts?
By setting your numerators.
Set my numerator equal to 0. All right, any questions so far? All right, next part. I need to know what my graph does at all these different intervals here. So I need to know where my graph is going to be on this side of my vertical asymptote. So less than -3, I need to know what the graph does. Where am I going to draw my graph? I also need to know from -3 to -2, what happens in this space? Is it up here or is it down here? So I have from -3 to -2. I also need to know between -2 and +1 what happens in this point right here, in that section. Is it down here or is it up here? And then I need to know greater than 1. So do you see where these intervals came from? Okay, so I need to know between each of those what happens. So this is what you do. You take your problem, all of your factors, all 3 factors, and you just write them in columns. See, this says x plus 3, x plus 2, x minus 1. They're all in columns. Then you're going to get the sign. When I multiply those together, you're going to get the sign, and that's where it's going to be. If it's negative, it's going to be below the x-axis. If it's positive, it's going to be above the x-axis. So, this is what you do. We're going to pick a number less than -3. And it doesn't matter what it is. -4, -5, -6, whatever. Let's just say -5. If I put that right here, -5 plus 3, I'm going to get what? A negative number, right? What if I put -5 right here? -5 plus 2 is a negative number. -5 minus 1 is a negative number. What happens when I multiply a negative times a negative? Positive times a negative is a negative. So that tells me on the left side of -3, I'm going to have a negative graph, which means it's going to be below the x-axis. Now, how do I know whether to draw it up in this area or draw it down in this area? Well, first of all, it can't cross the x-axis because I don't have an x-intercept up there. So I'm going to have to draw that right down here.